Yes.
Huh?
Yeah. So I'll also be sharing this recording to you so that you can look at it and understand it better. Okay.
Okay, wait, really quickly. So I was reviewing the SAT problems that we did last class, right?
Mm-hmm.
Um, can you re-explain 14 on the second module? I didn't take a picture of it.
14th.
Yeah.
Just the 14th problem.
Do you want me to send a picture? Yeah, I'm
Please.
sending a picture.
This one.
Yeah.
Yeah. So over here, x times 9x minus 2a plus b times 9x minus 2a minus x plus b is equal to 0. So in the given equation, a and b are positive constants, and the solution is x is equal to 42. So over here, wherever you have x, we can replace it with 42. Okay?
Yeah.
Will become 9 times 42 minus 2a plus b times 9 times 42 minus 2a minus 42 plus b is equal to 0. Now a and b both should be positive. And you have to find the value of a. Now we go to DESMOS. We
Mm,
have in parentheses 9 times 42.
wait, I already have it on my thing if you want me to share my screen. Okay, never mind.
I'll just type it in over here. 9 times 42 minus 2a minus 42 plus b. And this is equivalent to 0 because we want to find a parameter. Now you can see we're
Yeah.
getting a 1 and b is negative 42. But it's
Yeah,
clearly
I have
mentioned,
that down.
yeah, it's clearly mentioned that b and a and b are positive constants. So we have to take positive values of b. Okay.
Yeah.
So I'll be taking positive values of b. 1, 2,
Oh,
3, 4. And why we're taking b, why not a? Because we want to find what a is. So for b, we have the choice. And for here, from here, you're getting a is 188.5. That is our answer.
okay, thank you.
And you can convert it into a fraction also. It's 377.2. Got it?
Yeah, thank you.
Mhm. Shall we start with the DESMOS now?
Yeah.
Yeah. So DESMOS can be used to solve several things. First is solving equations. So first we'll see how we can solve linear equations. Let's say you have 4x plus 5 is equal to 8. We can directly type it in. You will get a vertical line and you can see the value of x is 0.75. All right.
Yeah.
Now, sometimes you do not want the line, you directly want the value. For that, you can use regression. And remember, for graphs, always use x and y. And for everything, for regression, do not use x and y. Use anything else other than x and y. Got it?
Yeah.
Yeah. So now, for example, if I want to solve this same equation using regression, what I would do? I would do 4c plus 5, and that is equivalent to 8. So you're getting the same value for c, or you can replace it with x1. So you can give any variable. All right.
Okay.
Here we are solving an equation, so no need to give any input parameters. Make sense?
Yeah,
Yeah. Similarly, in quadratic equations, we can do, for example, we have 3x squared plus 25x uh, plus 8 plus 16, let's say, is equal to 0. So now you're seeing two different points. These two are your solutions. Okay?
Mm-hmm.
Yeah. So whenever we are solving equations, this is how we solve the equation. So for linear equation, you write the equation, you will get one vertical line. For quadratic equation, you write the equation, you will get two vertical lines, you will get both the solutions. And sometimes you will not get anything because there is no solution. And sometimes you'll only get one line because there's only one solution. For example, if I write x squared plus 10x, we already have 16, so plus 8x. So now you're getting only one line. Okay?
Yeah.
It's only one solution. And now you'll not see any line because there's no solution. Make sense? And if you want to see if there's a solution or not, you can just make the graph. So you can see there are no x-intercepts. Got it?
Yeah.
Now in solving equations only, we have seen how to solve linear equations. We have seen how to solve quadratic equations. Now the next thing is how to solve other equations. For example, you have a rational equation. If I type it in, you can see the value is 37.5. This is also your linear equation itself. I will, yeah. Now, when there's any other equation apart from linear and quadratic, you will see that you cannot pick the points, right? I'm not able to click on them. So how do you solve this problem? Instead of writing the entire equation in one line, you write the left side of the equal to sign on one line, and you write the right side on the next one. And now you can see point of intersections, right?
Yeah.
So from here, you can get the values of x. These are your solutions. Okay?
Yeah.
So any equation apart from linear and quadratic, you have to separate them into two different lines. Does that make sense?
Yeah.
Also, sometimes it will just be equal to a number. Again, I'm
What
not
about Sorry. Keep
yeah.
going.
So when you just have a number in equal to sign, so if you write number, no graph will come. So you have to write y is equal to 8. When there's a number, you have to write y is equal to that line. And now we can see there's a solution 7, 8. So 7 is a solution. 7 is the value of
Okay.
x. Yeah. Now what you were saying?
Okay. What about exponential?
Same thing in exponentials. For example, you have 4 to the power x minus 3 is equal to, let's say, 13. So even now we cannot see the point. So what you have to do, you have to put them in two different lines. And you can write y is equal to 30. And now you can see the point of, look at the point of intersection of the y-intercepts. Point of intersection is x is equal to 2. So 2 is your answer.
Okay.
Got it?
Yeah.
So in case of linear and quadratic, we are just looking at the x-intercepts. But in case of any other equation, we're splitting them into two parts and we're looking at point of intersection.
Okay.
Okay. Same way you can solve for inequalities. For inequalities, you write the same thing. So from here, you can see 0.4 and it's everything beyond 0.4. So it's greater than or equal to 0.4. All right.
Yeah.
It's greater. If it's on the left, it's lesser. For example, if I make it like this, now you can see it's less than because you're going to the left. Okay.
Mm-hmm.
And similarly, you can have like exponential inequality as well. So again, you won't be able to see the point exactly. So but you can get the approximate value. So if it's a multiple choice question, then this is good. Otherwise, what you will have to do, but it's greater than, how can we get this value? Again, put this in the other line. .32193 is your starting point. So it has to be greater than 2.32193. Okay?
Mm-hmm.
Yeah. Any doubt over here?
No, I'm good.
And now in system of inequalities also, you write all the inequalities and then you see the common shaded area and whatever inequality satisfying, you work with that. Okay?
Yeah.
I'll also give an example of that. Example, let's say we have two different inequalities, 3x plus 4y is greater than -9 and x minus y has to be less than 8. So this is green, this is blue. This portion you can see over here. This is your shaded area. All right?
Yeah.
And now the multiple points will be given to you. From there, you can identify which solution works. So that is about your equations and inequalities. Any doubt in equations and inequalities?
No, they're not that bad.
Yeah. Now the next thing that we use it for is your modeling. Now, what is the meaning of modeling? Modeling means that you have to find the equation. Okay.
Yeah.
So, for example, several points will be given to you. Find equation from graphs or points or its features. Okay. So for this, you
Yeah.
have to table depending on whatever is given to you. So we'll discuss each one of them. For example, linear modeling. So when you have a linear function, you can write it as y is equal to mx plus c or mx plus b. All right.
Yeah.
So like how can you model linear function? What should be given to you? Either 2 points should be given to you. Or slope is given to you and 1 point is given to you. All right.
Yeah.
If slope and y-intercept are directly given, we do not need to come to DESMOS. We directly know what to do. But if there's any other point other than the y-intercept and there are 2 points, there's no slope given, then we'll come here. So what you will
That's when
do,
you make it. That's
what?
when you make a table, right?
That's when you make a table. Sometimes the points will not be explicitly given to you. It will be a word problem and you have to identify what are the points. All right.
Yeah.
Let's say it's given to you 3, 7, and let's say 5, 9. So you can click here. It directly says add regression. And it's a linear regression. You can directly see the equation is 1x plus 4. All right.
Yeah.
And sometimes what will happen, and you can export this regression on the next line also. Because in some questions, they give you 2 points. And for example, for the third point, they will give you either x value or y value. They'll be like, after 5 days, how much will be the answer? Like 5 days is given, but let's say after 10 days, how much will be the answer? So you can replace your x with 10. and you will get your answer as 14. Got it?
Mhm.
Or sometimes the y value will be given to you and you'll have to figure out x. So for that, what you can do, you can just put the y value here. For example, it's 700. And now you see where you're getting it 696. Okay?
Yeah.
Any doubt over here?
No.
So now you understand when to use linear regression?
Yeah.
Very good. Now, sometimes it's not necessary that the equation will be y is equal to mx plus b. For example, we were doing a question yesterday, which was on the form rx plus ty is
Oh
greater
yeah.
than or equal to 14, right? So this was rx
Yeah.
plus ty because we just want to know the equation of the line. We know it's going up. Inequality we can figure out later. First, we want to find the equation of the line. So over here, 2 points are given to you. Let me pull that question so that we can take that example as well. This
Mhm.
rx plus ty is equal to negative 77. And they will give you some word problem points will be given in there. They will directly give you the table or they will give you a graph. So from graph, you have to identify 2 points. Because it's a linear function, we need 2 points. So over here, this is one of the points. And this point is how much? It's 0, comma negative 11. And this is the another point. This point is negative 7, comma negative 10.
Okay.
So let me write the point 0, comma negative 11. Negative 7, comma negative 10. Now, this is not the equation we want. We want in this form rx plus ty, right?
Yeah.
Yes, so let me write the table again. So we won't go here because it will give you y is equal to mx plus b. We will directly write whatever it is as it is in the form of regression. How do we convert this into regression? X is replaced with x1, y is replaced with y1, and equal to sign is replaced with equivalent sign. So now this is rx1 plus ty1, and this is approximately equal to negative 77. You can see the value of r is 1, the value of t is 7. You're getting all the parameters. Make sense?
Yeah.
See if you get all of this and then we'll move forward. Yeah.
Yeah,
Shall
I
we
get
move?
it.
Yeah, got it. And when we will be using modeling, either they want you to find the equation. There are several questions. They say, what will be the equation for this particular graph, table, or word problem? Or sometimes they give you several points and they say what will be the answer at this particular x value or at this particular y value. Over there also, first you need to find the equation and then put it in. So in these two types of situation, we'll be using modeling. Now, after linear modeling comes your quadratic modeling. And how many points you need depends on how many variables you have. Here you had two parameters, R and T. That is why we needed 2 points. Now in quadratic modeling, there are two possibilities again. First, either
Mhm.
points will be given to you. Again, in the form of a table, in the form of a word problem, or in the form of a graph. But if 3 points are given to you, then you use standard form. And there you write y1 is ax1 squared plus bx1 plus c. And if you forget it, Don't worry, over here for quadratic regression, they give you the exact same thing over here. Make sense?
Yeah.
So over here, you can also just use the lines and you will directly get the quadratic regression in standard form. Okay. The problem comes when they will not give you 3 points. Or direct regression also you can use from here. Sometimes in some of the questions, what they will do, they will just give you 2 points. One of them is going to be your lowest point or maximum point, that is going to be your vertex. Meaning what they will say highest, maximum, lowest, minimum, something like that. So that you know they're talking about vertex and any other random point will be given to you.
Okay.
Okay. So in this case, you have to know what the equation is that you're going to use. So in your table, you can only use the point. When you're making a table, use the other point, which is not your vertex. And then in your regression, you will write y1 a times x1 minus h whole square plus k. H comma k is given to you, so you will write those values from here. Just substitute them here. Do not write h and k. Got it? And from there, you will get the value of a and your equation. So I'll show you an example also. Let's say one of the points given is 3, 7. And vertex, let's say, is given as 4, 9. So now you can see the value of a is going to be negative 2. So now you've got your equation. It's negative 2x minus 4 whole squared plus 9. Does that make sense?
Yeah.
So write everything about quadratic modeling. These are the only two options. Either 3 points will be given to you, then it's a no-brainer. But if only 2 points are given to you, you have to understand that you have to use vertex forms. And in vertex form, you already know the value of h and k. So I'm not writing h and k over here. I'm writing the actual vertex points over here. And from the second point, we can get the value of a. And then you can solve whatever you want to do. If x value is given to you, you just plug in x value, you will get the y value. If y value is given to you, you just plug it in, you will get the x value. Does this make sense?
Yep.
Shall I move forward?
Yeah.
And the third type of modeling that we do, there are only 3 types of modeling that are most commonly asked. That is your linear, quadratic, and exponential. So in an exponential, again, it's a times b to the power x. Sometimes, in very rare cases, it is a times b to the power x plus k, or so it will be like this, or something will be given in the question. So here also you need 2 points. And then you use your exponential regression, the standard one, or whatever is given to you in the question. If it is given in the question, then do not use the standard. Let's say I have this. And for exponential, you can directly go here, add regression, and you can see exponential regression also. It's 3.5535 times 1.25357 to the power x. So minimum 2 points you need to form exponential and linear. There could be more points given to you. For quadratic, it depends. For standard form, we need at least 3 points. For vertex form, we need only 2 points, but vertex should be given to you.
Okay.
Again, it could be a word problem. It could be a table given to you or graph given to you. Okay. Any doubt over here?
Nope.
Yeah. Now the third type is your system of equations. Now there are two types of systems of equation. First one is linear. Second one is nonlinear. Here it is both linear. One linear and one quadratic. And third one will be some random form that you cannot make sense of.
Like what?
I'll
Like
give you,
rational?
I'll give you an example. It could be percentage. It could be ratios.
Okay.
It could be rational. Okay. So for linear equations, it's pretty easy. You just write the two equations. You will get the point of intersection. It's over here. X value is negative 1.5, Y value is 2. All right.
Mm-hmm.
For one linear, one quadratic, you do the same thing. So if you can see, there are two solutions. This is one of the X value, this is another X value. And I'll just shift it so that you can see both the points. This is 2 point, and you don't have to do anything. They will directly give you the grade odds. You just have to look for the grade odds. It's 2.36277, negative 0.36277. Okay. Make sense?
Yeah.
Sometimes some random form, I'll tell you. We did a question like this. There was this ratio question. I don't know maybe that is. Yeah. For example, over here also you have 5x to the power k, 5 to the power x plus k. You want to find the value of k. So this is like a modeling question because you want to find out what k is, right? And
Oh
the
yeah, I
value,
already reviewed this one.
yeah. So we'll take 2 points and then we'll solve it together. There was this ratio question, if you remember. J over K value was given to you. So if I do
Also
an,
remember that one, yeah. I
yeah, you
redid
remember?
that one too.
Yes. So for example, I'll take 2 examples over here. First one is, let's say it is given to you that J over K is 62 and 96 over 12x, 96 J over 12x, J is equal to 62. And they're saying find the value of x. So there are 2 equations, right? And there are multiple variables and they're not making sense. There are more than 2 variables, but there are only 2 equations, right? So in this case, what you have to do, you have to make lists. Lists are like square, you write everything in square brackets. So in this list, what you will do, you will just write the left hand side. So you will just write J over K. That's your first equation. Then you will write comma. Left hand side of the second equation, that is 96J divided by 12x. And because we are using regression, instead of x, we will be writing x1. Okay. And now instead of equal to, I'll be writing equivalent sign. And on the right side, I will be writing all the right sides of all the equations together. So it'll be 62, 62. You will get all the answers. J is 62, K is 1, X1 is 8. See if this makes sense.
Yeah. I already reviewed that one, so I'm fine with it.
Yeah. So I'll take one more example. Okay, just give me a second. I have one more example. I'll take that. Yeah. So this question is like this. A is 764% greater than B. A is 0.96% of C. C is P% of B. Now they're asking what is the value of B. So now you see there are 3 different equations, right? First one is A 764% greater than B. So you'll be adding 100% to it. So it is A is equal to 864% of B, right? Now A is 0.96% of C. And now C is P% of B. So now what I would be doing? I'll be using the same approach. I will be writing it in the list form and I will just be writing the left hand side. So it's A, second one is also A, third one is C. And I've instead of equal to sign, I'll be writing equivalent sign. And again, I'll be forming list. First one is 864% of B. So I'll be writing it as it is 864% of B. Then 0.96% of C. And then P% of B. Correct? When there are like more variables but lesser equations, then this method is very useful. And now you can see you will get all the values. A is 8.64, C is 900, B is 1, P is 90,000. So the value of P is going to be 90,000. Got it?
Yeah.
So understand where do we use this? This is a system of equations, but they're making no sense. They're random equations.
I mean, I don't really understand, but I'll just review the video.
Okay, I'll explain it to you one more time. Were you able to see how we're getting these three equations, or you have doubt in this as well?
Not really.
You understand this or no?
I mean, yeah, I understand this, kind
You
of. Like, I understand the basics.
Because A is 764% greater than B. When it is a
Yeah,
certain percentage greater, you'll be adding 100% to it, right?
okay,
And A is 0.96% of C. I've just written it like this. A is 0.96% of C. I've done nothing.
okay.
C, we have just written C is equal to P% of B.
Oh, okay, wait, I get it now, I get it.
Because, and now what I'm doing,
Yeah,
I'm collecting all the left sides on one side. So I'm just writing A, comma, C. And then instead of equal to, I'm writing equivalent. And I'm collecting all of this, the right side onto one side. So I'm just writing 864% of B, comma 0.96% of C, comma P% of B. That's it. You'll get all the values. Now do you get it?
yeah,
Yeah. Any doubt over here?
no,
No. Very good. So we have seen how we can do modeling. We have seen how we can do the system of equations. We have seen how can we do normal equations and inequalities. Correct? Yeah. Shall we move forward?
yeah,
Now, sometimes equation is given to you and you have to get the table, right? Some questions are like that. Some random equation is given to you and some table is given to you. What you do then? You go to edit list, you create a table. And then whatever options are given in the question, because all four x values will be the same. You just write those options and see where it is matching. Got it? So you can
yeah.
also go from equation to table in DESMOS. You can go from table to equation and you can also go from equation to table. All right?
Yep.
Hmm.
Oh, wait, this is like limits, right? No,
Not,
actually, never mind.
this is not limits. And
No,
sometimes there will be inequality. For example, sometimes it'll be like 5x plus 7y is greater than 9. Let me take a better example. Let's say 5x squared plus 2x plus 3y is greater than 5x squared plus 2x plus 3. Okay. So now what you do, you type 5x squared, and in the options, there will be tables. 2x plus 3. You again create the table and you put your x values. Now y value is 339, but y is greater than this. So now what you will do in your options, you will choose a value greater than these values. Understood? And if it is less than, then choose lesser values than these values. Choose that option. Does this make sense?
yeah,
Hmm. So shall we move forward? Hello?
Yeah, ऐसा ही है.
Yeah. Now comes the third thing, that is your equivalent representations. So now sometimes they will just give you one equation containing one variable and four options will be given to you. You can plot all the graphs and compare them. Got it?
Yeah,
So if only one
this
variable
is
is given, you can plot all the graphs and compare them. Like it's just like, for example, in the question they are asking what is equivalent representation of x squared over 2 plus 3x over 5 plus 7 over 2x, something like that. And the options are given to you. Option A, option B, option C, option D. There's only one variable x and everything else is known. So what you do, you type x squared over 2 plus 3x over 5 plus 7 over 2x over here, you will get a graph. And then whatever options you have, you plot those graphs as well. And where they exactly match, that is your answer. Got it?
yeah.
So yeah, you can write this down and then we'll see what if there are more than one variable.
Okay, I'll take a screenshot. I'm good now.
Yeah, just give me a second. So these are some of the questions that we are going to try. This one is easier without DESMOS, right?
Yeah,
Yeah. Now questions like these. P is equal to 3x plus 4, B is equal to x plus 5, PV minus 2P plus V you have to identify. And there are several options given to you. All right.
yeah,
So you write P is equal to 3x plus 4. You are getting a graph because again there's one variable, V is equal to x plus 5. Again, you're getting a graph. Next, you have PV minus 2P plus V. Again, you're getting a graph. And you can hide these because you do not want to compare the answers to these ones. Okay. So you have PV minus 2P plus V, you're getting a graph. Now what you can do, you can type all the options and see where the graph is exactly matching. For example, 3x squared plus 12x plus 7. It's not matching, so this is not the answer. And 3x squared plus 14x plus 17.
okay.
It's completely matching, you can check it. So option B is your answer. If there's only one variable, because P and B, they're also comprising of one variable, so it doesn't matter. And in your options also, you just have one variable. You can go through with this method, just comparing the graphs. And you can write everything as it is, whatever is given in the question. P is given, you write that. B is given, you write that. Which equivalent they want, you write that as well. And then you write all the options. Make sense?
Yeah,
Same thing over here. You only have one variable, you write this equation, you compare with the graphs, you will get your answer. Same thing over here. Same thing over here. Now comes these kind of questions. Over here, what will happen? There will be some, for example, this is a function of x, but some parameters are missing. What are parameters? These values, the coefficients of x or some constants are missing, right? So that is the second type. How will we do this? So for this one, for these kind of questions, so the first one was there's only one variable and they just want the equivalent representation. You're just comparing the graphs. Second would be two equivalent representations are given to you. But some parameters are missing. So here you will write equivalent representation 1, equivalent to equivalent representation 2, and then you will see what is your input variable. So whatever your input variable is, in most cases it is x1, but not always. So you will write x1 is equal to, you will give some certain random value. So you can always give 1, 2, 3, 4, 5. Okay. So there is equivalent here, but there is equal to over here. Here you will get all the values of the parameters.
Okay.
Understood?
Yep.
Use this kind. So now, for example, over here, I will be typing it ax and replace your, if it is x, replace x with x1. That's a given. Whenever you're writing equivalent sign does not identify x and 1. So let's write this equation and try to solve this. So it's ax plus 3, 5x squared minus bx plus 4 is equal to 20x cubed minus 9x squared minus 2x plus 2. So we will be writing ax1 plus 3, 5x1 squared minus bx1 plus 4. And this is equivalent to 20x cubed minus 9x1 squared. And here also, and how to make x1, just after x write 1, it will become x1 minus 2x1 plus 12. You're directly getting the values of a, but here you are getting x1 as well. But we know that x is your input variable because this is a function of x. And only a and b are constants. Okay. So in the next line, what I will do, I will give values for x1 is equal to, you can give any 5 values. And sometimes read the question. For example, sometimes it will say x is greater than 2. So take values which are greater than 2. In normal cases, you can take 1, 2, 3, 4, 5. Now A is 4, B is 6. They are asking for the value of AB. Now you can just write AB. You directly get your answer 24. Does this make sense?
Yeah.
Still remember this? Shall I move forward?
Yeah.
This is your previous one. You can compare the graphs. Okay, now you want to find the factors. So whenever you want to find the factors, you can directly plot it and you can get the factors as it is, right?
Yeah.
Yeah, it's the same. It's what we did right now. Your input variable is x. So you write everything as it is. Instead of x, you replace it with x1. Equal to, you replace with the equivalent sign. And you will get the two different values, a and b. You can do a over b. You will get your answer. Okay.
Yeah.
And how to write square root, cube root? So for square root, you type SQRT. For cube root, you type CBRT. So it becomes cube root. And for any other root, you type NTHROOT. So now you can get fourth root, fifth root, whatever you want. Okay.
Yep.
This is also just comparing the graphs. This is also making equivalent. And then over here, your input variable is y. Though you can solve it without DESMOS also because it's a very easy question. But if you're doing it with DESMOS, you will replace y with y1 and now you will give the values of y1 because y is a input variable. How do we know? Because r is a constant. So r is not your input. Make sense?
Yep.
Same thing, it's equivalent. And yeah, so I was saying sometimes it'll give you things. For example, x is greater than 2. So you will take x1 values at 3, 4, 5, 6, 7.
Okay.
This is also just comparing the graphs. For example, over here. It's also the same question, but what mistake you can make? Because they're asking the value of x. So x is not your input now. And it is given that n is greater than 1. So instead of x1, you will be writing n. So I will do this one as well. I'll write the question. So it's 5th root of 70n times 6th root of 70n whole square. And equivalent means it is equivalent to 70n to the power 30x. So I'll be writing nth root 70n, nth root 70n whole squared. And this is equivalent to 70n to the power 30x1. Now in the question only they want to find the value of x. So that means you by yourself will not give the values of x. You will give the values of n. And n is greater than 1, so we'll be giving 2, 3, 4, 5. So the value of x1 is 0.01178. And if you want in fraction form, you write x1 here, you get the value. You can convert from fraction over here. Got it?
Yep.
Any doubt over here?
No.
Yeah, it's the same kind of question because it is equivalent to. So here x is the input variable because a, b, c, and are constant. So you'll give x1 is equal to 1, 2, 3, 4, 5. You'll get all a, b, and c. And then you can answer the question. This is just comparing the graphs. Yes, sometimes you will not get the values. So sometimes you have to solve manually if DESMOS is not working. For example, here also g of x is given, h of x is given. You can simply write g of x times h of x and then compare the graphs with the options. Yes. Now this kind of question where you have two variables and you have to find equivalent expression for it. Okay.
Yeah, this one's not too hard though.
Yeah, this one is not too hard because you can solve it manually. Because cube root means you have to divide the powers by 3. So this will be xy squared. But sometimes it could be there's only one variable you can compare with the one variable, the graphs, just replace b with x.
Okay.
Yeah, now over here. You have x squared a plus b, you have y squared a plus c. And you have to find x squared minus y squared whole square. So there are various variables. There is there are a, b, and c, right? So for these kind of questions, what you do, you take some random values of a, b, and c. You can take anything, but just don't take one because with one, it's always tricky that you might get answer 1 or don't take 0. All right.
Yeah.
So for these kind of questions, if there are multiple variables, give all those variables a single value. For example, you're giving a is equal to 3, you're giving b is equal to 2, We're giving c is equal to 4. And now x squared is a plus b. Y squared is a plus c. And you're looking for x squared minus y squared whole square. Okay?
Yep.
Now what to do? Because x squared you're getting graphs, you do not want to get the graphs, you want to get the values. So you'll just write x1 here. And when you're writing x1 instead of equal to, you'll be writing equivalent. You will get a value 4. Okay?
Yep.
Now just type all the options and see where you're getting the value 4. So when you have multiple variables, and if you're writing equivalent expression, what you have to do, you have to give each way, because here on the left side you have A, B, and C. So you're giving one value to each one of them. Okay? You will get some value for x squared minus y squared whole squared, and you compare with all the options, you should be getting 4 as your answer. Wherever you're getting 4, that option is correct. Make sense?
Yeah.
For example, over here, you can solve it manually. But let's say if you do not want to solve it manually, again, what you will do? You will give some value for x1. You will give some value for y1. Then type in this equation. You will get some value here. And now you type all the options. And we'll be writing equivalent, not equal to, because x1 cannot take equal to. And wherever, here also you'll keep getting your multiple answers. And wherever these two matches, that is going to be your answer. Okay?
Mm-hmm.
Correct?
Yeah.
Example over here, you have A and K. So give any value for A. You can solve it manually also because it is also easy question. But if you do not know, then you can give any value of A. You can take any value of K. Just write 42 A over K plus 42 AK. It will give you a value. Now type all the options and just see whether they match. They match with this one. So this is your answer. All right.
Okay.
Neat. So that's everything about DESMOS to know for now. So you will know what to use and when to use.
Okay. Thank you. Have a good day.
No, we are extending the class.